All right. Very good morning, everyone. Welcome to this Oracle RAC administration workshop. Uh, these are going to be 2 demo classes today and tomorrow. I want to make it so interactive. Everyone can allow to unmute and ask any questions during my explanation. Uh, Very first thing, I'll try to introduce about myself and followed by my course curriculum, and then the course duration and course structure and the timings, followed by course fees structure. And then we'll be try to cover basics of rack architecture on this today's session. So just to brief out myself, I'll be having overall 12 plus IT years of experience, purely on various industries, like starting with the finance sector, insurance, and retail business, and so many other industries, right? Like I worked in all these 12 years, various organizations, starting with the iGate, Oracle Corporation, and EXA group of companies, and Wipro, and then so many other companies. And then I started my career after my graduation as a software engineer, and then become a senior software engineer and lead engineer, and started supporting at infrastructure level. Uh, and then apart from that, I worked on various Oracle product. Oracle is my primary focus and primary key area. I am a Oracle database certified OCA OCP, Oracle RAC certified expert, Oracle Data Guard certified expert, Oracle Exadata certified expert, Oracle e-business certified expert. And also I worked in Informatica admin, OBI administration, and also I worked for MS SQL database, MySQL database, PostgreSQL database. So apart from all these, Oracle is my primary area, primary key skills. And in entire my career, to be frank, I handled many projects, many clients, and few of the best projects so far in my career was, we built uh, entire data center setup for one of the client in Gulf from the scratch, almost around 4,000 servers, including EBS, OBI, Informatica. Uh, we did it from the scratch. So that entire data center build, that's a major activity I performed. And also for one of the, enterprise customer, we did an entire data center migration with a minimal downtime. So that will be from New Jersey to Washington DC to New Jersey. So entire data center migration with a minimal downtime. Those are the major projects or activities what we handled in my career. Apart from that, there's so many activities like building data guard, RAC, Exadata, implementation of Exadata, implementation of EBS, implementation of ODA, implementation of Exalogic supercluster. So many other activities are commonly done. And also in my career, I almost done around 200 plus clusterware upgradation from 11G to 12C, from 11G to 19C, 12C to 19C, 200 plus cluster upgrades, and 400, 500 plus database upgrade and migration. So many things. Yeah, that's all my experience. And this particular RAC course, he's built based upon what I learned so far in these many years of experience. And as a RAC expert or as a RAC DBA, what you should learn, what you should understand, because each and every DBA, many times I used to see, like, they struggle a lot when it comes to RAC, and then they'll not be able to understand how exactly RAC works, and they will lack of basics. Once you understand what's the core concept of RAC, how the RAC works, what are the differences between your core DBA or core database to RAC database, then it was so easy to manage, and you can easily handle any situation when it comes to rack. So this particular course is defined such a way that, as a rack expert or as a rack DBA, once you start working in any client or any customer, as a rack expert, what are the day-to-day activities? What all, as a rack DBA, we need to take care. All those considering, this particular course is formed. And also, I'm gonna call this course as a rack administration workshop, because each and every concept, whatever I'm going to explain, everything will be, demonstrated and given an explanation to the real world. So because of that, will be consider this as the rack administration workshop. The moment I show the live demonstration, at the same time you will be executing, or you will be, carrying out with your lab exercise along with me, so that, both will be doing a live examples and then practicing each other. So that's why, I used to call it as a rack administration workshop rather than rack course or the rack class. Right. So that's about my introduction, and then the basic idea about how this course is formed. And now I can quickly jump onto the course content. Uh, let's quickly. So you can stop me if you have any question, because everyone are allowed to unmute yourself and then uh, just ask any questions. Right. If you are looking for this course content, and pretty much you can go here, this particular blog, um, and then you can search for this course curriculum here. I'll just quickly touch base on course curriculum. We'll start with the introduction to my clusterware, where we will understand what's the difference between my standalone database versus rack database, and then why we can call it as a rack, and what is, so many people will be having doubts, what is clusterware, what is ASM, what is grid infrastructure. To be frank, if you try to differentiate your ASM, your clusterware, and your grid infrastructure and your rack, so there are a lot of confusions. But we start with the basics here. We'll try to understand each and every keywords: what is clusterware, what is rack, what is grid infrastructure, what is ASM, what is rack database, how to verify whether it's a rack database or the standalone database, all those basics things. And then what are the networking concept is going to change, when it comes to rack, right? So all will be like start explaining it here in the basics understanding of clusterware, and then followed by your rack architecture, right? So we know like database architecture, everyone can read and understand, but when it comes to rack, uh, and people will be like having a difficulties or challenges to understand the rack architecture. The reason behind that is lack of resources, lack of infrastructure, because they never logged into any cluster database. If you're not logged into any cluster database, or you are not handling any rack database, so you will struggle to understand rack architecture, because the all the words are going to be like new. Like, if you suppose, for example, you may get VIPs. What is VIPs? You may get a scan. What is scan? You may get a scan name. You may get a cluster name. All these keywords will get confused, and then people will start ignoring that, and then they will not be able to understand the architecture. So we'll start with the rack architecture, and we'll start to try to understand rack architecture with comparison with the standalone architecture, and then how this rack clusterware will be formed. What are the major components which will help us to build my rack clusterware? For example, your OCR, routing disk, your scan, all will be like, we'll try to understand, and then followed by your clusterware startup sequence. So, in order to form your clusterware, there are a lot of background processes or a lot of daemons will be like get started, and then in which order they will get started. All this clusterware startup sequence we'll understand here in chapter number 1 and 2. I think Kadir, you have a question.
Yeah, hi, Mallikarjun. This is Ahmed. Can I
Yeah,
ask a question?
yeah, please.
Uh, Thank you. Thanks a lot. As you have mentioned that together we students who are going to learn and you are going to work on the workshop, the machines what you have. So individually, other than working with you in a practice sessions, other than the 2 hours which you are going to provide with us, Other than this, can we individually connect to the servers whenever we want for a practice sessions? If I'm, for example, if I'm installing rack or just adding a node or any activity doing a patching, so anytime I
Right.
can connect to the servers and do the activities.
No, this is not a online or live servers. Whatever the lab setup we are going to do it, it will be on individual laptop using a Oracle virtual box. There are no servers at cloud or there are no servers at online. You had
Mhm,
to build on your own laptop.
mhm,
There are ready labs. I'm going to come to that point. There are like so many ready cluster labs already uploaded into Google Drive. You just need to
mhm.
download them and you need to configure on your own laptop using Oracle VirtualBox.
Okay, okay, sure.
Right. These are the first two topics we'll cover on the basics, and then followed by next uh, three chapters here, right? Next four chapters. We'll start with the Linux installation and configuration because that's a very basic need. When we are gonna be like expert or when we are gonna be like strong in our domain, when you do a practice, and then for that, each and everyone has to understand how to set up our rack cluster. For that, we'll start from the scratch, like start from our Linux installation and configuration, and then followed by network installation and configuration. So we're going to do here two cluster nodes, two VMs. We're going to configure here. We're going to install and configure two VMs, and then followed by we're going to do a networking configuration between those two VMs, node 1, node 2, and DNS configuration, and your name resolution, forward name resolution, reverse name resolution, your scan name setup, and your VIP setup, all will be like done here in this network configuration. And then after setting up of your two node rack servers, you have to create some shared disks. So we're going to create some shared disk between those two servers, and once that is done, so we'll start with the clusterware installation. That's your infrastructure installation, or you can say it as the ASM installation or clusterware installation or grid infrastructure installation. So I'm gonna explain what are these three keywords. But in a simple terms, your ASM installation or your clusterware installation or your grid infrastructure installation are all going to be same. In prior to 10G, we used to have two separate installation. One is your clusterware and other one is your ASM. So those two are going to be like two separate Oracle home we used to install, clusterware home and ASM home, and we used to install ASM separately and clusterware separately. And starting with after this 10G release to the Oracle has clubbed this clusterware and then this ASM together, and they called it as a grid infrastructure. So that's what we're doing it here in the chapter number 5. We will do some pre-checks. We'll do install our ASM or a clusterware or grid infrastructure, and my ASM and my ASM disk groups are all ready. And then here we are going to do Oracle home installation. We need to install Oracle home on both the nodes, node 1 and node 2. Once we install our Oracle home, and then we'll create some shared disk groups. Out of those shared disk, whatever we created here, shared disk, with this use case, by using this shared disk, we're going to create some shared disk group like data, RICO, and other things. And once the disk groups are ready, we are good to start with our database installation. So database installation, like you can go with the silent mode or manual mode, or you can go with the DBUA or so DBCA GUI method. You can go ahead and then install your two node rack database. Once your rack database is done, so that concludes our installation or configuration here. And then we'll followed with the regular architecture and all the basic admin tasks and other things. In the chapter number 9, we'll start with the ASM architecture. So once the lab is ready here, and then we'll start with our ASM architecture. So we'll deep dive into ASM, and then why we need ASM, what are the uses, and what are the advantages of ASM. Can I set up my rack clusterware or rack setup on file system? Can I set up my rack system on ASM? And then why this ASM came, what are the storage importance, and then how disk groups are formed, how my database will communicate with my disk group, ASM disk groups. All those will understand here with the architecture, and then followed by your administration in ASM, how to create a disk groups with manual or with a GUI mode, and then how to add a disk, how to drop a disk, how to create a normal redundancy, high redundancy, and external redundancy, various types of redundancies in while creating your ASM disk groups. So we'll play around that these groups, because those are like common tasks. As a DBA, we used to regularly add a disk into my disk groups. And sometimes whenever we're creating a new database, we're going to create a brand new disk groups for my databases. So those all tasks will be covered here. And then followed by your clusterware and yeah, somebody has question. Right. So in chapter number 11, we'll start with the clusterware and rack administration, like, your CRS-CTL and SRV-CTL, right? So those are two important things. As a rack expert, we always use CRS-CTL to manage my clusterware. In order to manage my database, I always use SRV-CTL. When to use what all commands are supported with CRS-CTL, SRV-CTL, and sometimes we run CRS-CTL with a root user. Sometimes we'll run with a grid user. We're gonna explore more on that CRS-CTL and SRV-CTL, and restarting your cluster services and restarting your cluster nodes, restarting your databases, and rebooting your cluster nodes. All those will be like demonstrated, and then what all the logs we need to check, how we can troubleshoot when your cluster is not starting. All those things we are seeing here. And also some of the your cluster level resources, right? Like your scan, your VIPs, your voting disk, your OCR, and your OLR, local registry and cluster registry, and your cluster resources and services, your VIPs, scan IPs, and public IPs. All those will be like discussed, and then how we are going to change your VIPs, change your public IPs, change your voting disk, how you can back up of your voting disk, OCR file, OLR file. All those will be like explained here. And followed by your rack administration. We know like we set up our rack database, but how to manage that, and then what are the importance factors I need to consider, and how my redo logs are distributed across my rack databases, how my RK logs are distributed, how my P file, SP file resides, where is my password file, what are my table spaces, which instance it will be decides, how I can manage that both the cluster instances. If one instance goes down, how I can sustain with the other instance, how I can distribute my load across cluster nodes. What is the measuring factors that load is distributed across my cluster. Sometimes often we see that all my end user connection or application connections are going to node one only. What's happening? Why my other cluster node is not taking any load? Why nothing is running on that other node? So all this we'll try to explore on this rack database administration. And when it comes to backups and recovery, that's going to be one of the key factors for the DBA. Key factors for DBA, right? Like I always used to tell that there are three major areas as a DBA we can support for any client. One is your basic monitoring activities. Any junior DBA can handle that, and he can monitor that, making sure that your database listeners and your applications is up and running for 24/7. So that is basic monitoring activities, anybody can do it. And then apart from that, the second major task as a DBA is your backups and recoveries. How good and how strongly you can build your backup and recovery strategy, right? Because in case of any disaster, in case of your production database crashes, or your production data center crashes, due to any disaster or anything goes wrong, how quickly you can rebuild your production database, how quickly you can bring back your business online. That all depends upon how strong is your backup strategy. So we're going to understand various types of backup, especially in RMAN, level 0, level 1, archive backup, and database full backup, and what are the tuning factors in order to make your backup faster. And then by making use of those RMAN backups, how you can restore, how you can recover, and then also how you can duplicate your database. So often we used to get a request from many developers or end user that, I want my production database copy into my development server. I want my production database copy into my test server. So those all duplicate scenario, everything will be covered here in this particular RBAN backup, rack database backups and restores and recoveries. And then followed by your listeners. So we'll try to understand, because if it is a normal database, it's a single listener, and then all database connection will go to that. But when it comes to rack, there are so many listeners comes into picture here. ASM listener, scan listener, and database listener. And then in that, you can see some of them are local listener and some of them are remote listeners. So what are the differences? Why we need so many listeners in my rack? So we can understand and how we can make sure that connections are going through scan and then load is distributed. So your scan listeners play very, very important role on that, distributing the load. So that we will check it out here in this particular chapter number 15. And then followed by your multi-tenant. It will be like purely starting with 12c onwards, Oracle has came up with a new architecture, that is a multi-tenant architecture, container database and pluggable database, CDBs and PDBs. So we'll be purely dealing with the RAC CDBs and RAC PDBs. So we'll start with the understanding of your our core concept of multi-tenant architecture, how it works with the standalone versus RAC, and then followed by we'll see so many CDBs and PDBs cloning, how we can install the PDBs, how we can clone the PDBs, and then your CDB versus PDB, cloning of your CDBs and cloning of your PDBs, and how we can connect to CDBs, how we can connect to PDBs, how my listener will handle the CDBs and PDBs, how you're going to connect your CDBs and PDBs, how you can connect with the username and password, how you can connect with OS authentication, how you can connect with your TNS names, and then how I can configure my listeners and TNS for my CDBs and PDBs. So all this will be like discussed over here. And then purely this is all based upon the rack, nothing about standalone here. And followed by your ACFS. ACFS is one of the widely used
I have a
one.
question with respect to a container database.
Yeah, please go ahead.
Yeah, so sir, recently actually we started migrating the database from 12c to 19c. Some of the clients say just migrate the database in the CDB format. Some of the clients says let's migrate into the same way as we have in 12c non-CDB. So what is the best practice?
No, I did not get the question. You want to migrate?
The question is from 12c to 19c, we are migrating our database.
Right.
Okay. So when we ask to the client and and Oracle as well, they say you just to migrate to the your database in the CDB form. Okay. But sometimes client says you just to migrate in the same way like we have in the in the non-CDB form. So what is the best practice? We should migrate our database in the CDB or non-CDB from 12c to 19c.
You can go with the normal database upgrade, right? It's not a migration. When you're doing 12c to 19c, it's called upgradation. So upgradation, you can do it in-house on the same server.
Upgradation we have done in like non-CDB, and now the request come to convert the database into the CDB.
Oh, like, okay, you were talking about non-CDB, you can convert into PDB.
Yeah.
Like, see, what happens here, right? You have your 12c database. It's a 12c database. This is not a container database. It's just a database. I can say this is a DB1.
Yeah, non-CDB. This is a non-CDB.
Right. And then you have your 19c database here. This is your CDB database. So you have your CDB database. So this 12c database, whatever the DB1 non-CDB, you cannot make it as a CDB here, like, you know, CDB and then DB1. You cannot make it as a container database here. This entire 12c database, you cannot make it as a container database. Rather, this 12c, you can plug it as a PDB inside any one of the container database. So you have this container database here. You can plug this as a PDB inside this particular CDB. There is no option. You can convert your non-CDB as a CDB. Or you can convert that non-CDB as a PDB inside one of the container database. That's a supported approach. You have to follow that.
So it just become mandatory to to create our database or migrate our database in a CDB from 19c onward.
Yeah, there's no option at all. Like, you know, you cannot convert your non-CDB directly to a CDB. So there's no option at all in 19c. Even in 21c, there's no option. So first you need to convert your non-CDB as a PDB inside any one of your container database. Once you migrate is done, later you can do upgrade. There is no direct approach. There is no, not even like even 21c, you cannot do direct migration.
So, sir, actually, I have to migrate to the 50 database server. They all are on the 12C, okay, on Oracle RAC,
Right.
and so we have to migrate on the new server. And this we have already close to the, clear to the client. We all are going to migrate in the CDB. Okay, what we'll do, we'll just these are like some of them the database size is less than 1 TB. Some of the database size is more than 1 TB.
Right.
So based on the database size, we are deciding the strategy.
Right. So I can quickly explain, like converting your non-CDB to a PDB. You are going to convert your whatever the 12C non-CDB, you're going to make it as a PDB. There is no direct option. Whatever this non-CDB, you cannot convert it as a CDB. There's no option at all here. So it is supported with the 12.1 onwards. So there are like hardly 4 steps. One is you're going to run this DBMS PDB check compatibility. Once this compatibility check is done, so you're going to bring that 12C database in mount mode. Once mount mode is, you started your 12C database, you're going to put that database in read-only mode. Once you put your database in read-only mode, you're going to run this DBMS begin package. You're going to create one XML file. And then you're going to take that XML file and you're going to check for that compatibility. Whatever that XML file you generated, you're going to check for that compatibility in your target server, in your existing container database. The moment you run it, if the compatibility matrix comes with a yes, then you can proceed with the migration. Like, you're going to connect to your container database. Once you connect to container database, you're going to run this create pluggable database using that XML file, whatever you created. And then if your file system is different, you're going to use this file name convert. If the file system is changed, if it's going to same, you're just going to run that create pluggable database using that XML file. You're going to create a PDB. So this is the only process you can convert your non-CDB as a PDB. But so far, there are no direct method you can convert your non-CDB as a CDB.
Okay, yeah, thanks for sharing it. And sir, is it Oracle has just made this a mandatory from 21C onward? You have to work with the only a CDB database. You can't work on the non-CDB.
Right. In 21C onwards, it's all PDBs and CDBs. There's no normal database at all. In 19C, when you're trying to create a database, you have an option whether you want to create it as a CDB or you want to create it as a non-CDB. That option is there in 19C. But when you try to create a database in 21C, the option is removed. Default, it will be like your CDBs and PDBs.
Okay. So my request is to like in this course, you just create the only CDB database so that we can,
right,
just follow that practice.
Right.
Thank you, sir.
Yeah. So we'll be covering everything, right? Whatever explanation we'll be covering, comparing both CDBs and PDBs, and also your normal databases. So this will be like purely dedicated on that, various methods of cloning and understanding on that, and followed by your ACFS. ACFS is one of the widely used case when it comes to RAC database. Some part of your disk group, you can mount it as a normal file system, and then you can make use of that. So I'm going to cover, we're going to start from the scratch. We'll configure our ACFS file system, and then we can mount it as a normal file system, and then you can use it for your export, import, and in fact, you can create your database on this ACFS file system, normal file system file database here. And then we'll understand with RAC one node versus your RAC database, what's the advantage, what's the use case of RAC one node, and followed by your clusterware patching, your whatever your ASM grid infrastructure, clusterware patching, and your database patching. And you can use OPatch auto and manual patching using OPatch. We're gonna do a entire patching activity here. And then we're gonna see that rolling patching, non-rolling patching. So when it comes to RAC, how to avoid a downtime, you can go with the rolling patching. Bring down your node 1, do a patching on that, bring it up, go to node 2, bring down your node 2, and then patch it and bring it up. So how you can do that rolling patching. Non-rolling, you can bring down both the cluster nodes and do a patching and then bring it up with a minimal downtime. So you can do rolling, non-rolling, all those things will be extended here. And we'll be doing clusterware upgrade and RAC upgrade. We'll be doing one 12C clusterware installation, and then we'll do that upgradation of our clusterware from 12C to 19C, and also we'll do some database upgradation from that 12C to 19C, how we can do for RAC database upgrade here. And then we'll install one more node. So right now we'll whatever practice we do, it is a 2-node rack. And then here, when it comes to chapter number 21, we will install one more Linux server, node 3, and then we are going to add that node to my existing cluster. What are the steps we're going to take it? And then later we'll remove that node. We'll make it as a 3-node cluster, and then later we'll remove one of the node, and then we'll make it as a 2-node cluster. And then we're going to convert how you're going to convert your single instance to rack. Various method, DBCA, your enterprise manager, rconfig, or some manual steps, manual commands. So how we're going to convert, we're going to demonstrate on that. At the end of the course, we'll be covering some resume and cover letters and some of the LinkedIn profile and other important things as a rack expert, what all I need to mention in my resume, and then how I can apply for the job via LinkedIn or some of the job portal. We'll all will discuss here. And again, some of the at the end of the course, we'll touch base on regularly asked interview questions and answers. Again, this is not limited to chapter number 15, chapter number 25. And each and every topic I'll be giving a hint on, like, what is important here, what kind of questions will come on each and every topics here. And at the end of the course, we'll be conducting the mock interview. Again, that is subjected to your individual interest. So if you're interested, you can register, and then I'll be connecting with you one-to-one, and then we'll be discussing on this.
Sir, are we covering the rack troubleshooting here?
I think will be
in
covered.
case of any of the
like it will be covered here. Right. It will be covered here. Your clusterware administration here, right? So you are rebooting the node, and then if you're which log to check, what are your startup sequences, and if that service is not starting, and then once you understand your clusterware startup sequence, and then you can easily troubleshoot. Like, you can easily get to know that which log to check, and your OHSD will start after that. Your CSSD and CRSD. If you know the sequence, you can quickly go ahead and check for that particular log. I will be discussed here on this.
Okay, thank you, sir.
Right, so that's pretty much about course curriculum or course content. And then any questions on this course curriculum, or and then any topic need to be included, you're all welcome. You can give any suggestion on that once we start our course. And then we'll be having a dedicated WhatsApp group for each batch, and we'll be communicating, we'll be discussing on that particular WhatsApp group. And then you can provide any feedback or any particular topic you want to discuss, that will be like included as an extra topic, and then we can touch base on that. We can cover that as an extra topic on after the course. Right. That's about the course. Yeah. Yeah, please.
What are the minimum requirements that we shall have in our laptops and desktops? Can you discuss on that?
Yeah, we need a minimum of 16 GB RAM in order to set up a 2-node rack. We need a minimum 16 GB RAM. If it is lesser than that, it will be very, very difficult. You cannot do an installation because your installation will get hang. If, for example, if you have 8 GB RAM, you cannot do installation. But however, you can download and you can use it, but that will be very slow. Your laptop will be slow, your VM will be very slow. Minimum 16 GB RAM, and your hard disk should be 100 GB. So 16 GB RAM and then 100 GB hard disk, that's the minimum requirement.
Processor, any specific processor, i5, i7 like that?
I think nowadays latest will be like, I hope like minimum will be like i5, most of us will be having, but if it is the lesser than i3 and i4, I'm not sure, like that's a pretty old 19C is be like, if you have minimum i5, that'll be good. Otherwise it will be your even i3 you can install it, but it will be very slow.
Okay.
Hi Malik, this is Amrita here.
Yeah, Amrita.
Yeah, hi. Hi, I'm not sure if I missed that, but are we having this OS Watcher analysis and all included in this?
No.
Okay. So, like you just mentioned, if we want to cover anything, so is that part of something else that you're going to, like, is that part of your course in anywhere, or it's not part of the rack?
No, it is not included with structure analysis and all. So if needed, we can take it as extra class, but
Mhm.
yeah, it is subjected to who all are interested. Like, we'll be regularly, many people are, if
Yes, sir.
they interested.
We are interested actually this kind of to dig dag into the issue. We need to just to watch review the logs, voice watcher logs.
Yeah, so if many of them interested, then we can take it as extra class, but it's not part of this course as of now.
Okay.
Yeah, it's again depends, like, who all are interested, how many of, like, once we start our classes, right, many people will be like requesting for many topics,
Right.
and then we can take it few of them, and then we can cover it as extra classes.
I see.
Hello, Malik.
Yep.
Yeah, I want to know that its class is regular or it's weekend on weekend.
Yeah, I'm coming to that. I'm coming to that in a minute. Right. So we just today and tomorrow are going to be 2 demo classes. Saturday and Sunday, what we're covering 8 a.m. to 10 a.m. 2 hours today and tomorrow 2 hours. This is going to be 2 demo classes, and the actual course is going to start on 19th July. So if I get my calendar here, today and tomorrow, that's Saturday and Sunday. So 2 demo classes, and our actual classes will start on 9th of July, that's Saturday. So this batch is going to be on weekend batch, only Saturday and Sunday. So the next Saturday, next weekend is the one we're going to start our actual batch, and that is going to be 4 hours each of those weekends. For example, if I go here 9th and 10th, so the coming weekend when we start our next class, it's going to be like 4 hours on Saturday and 4 hours on Sunday. It's going to be like 8 a.m. IST to 12 a.m. IST, 4 hours on Saturday and 4 hours on Sunday, and then it's going to be on weekend batch. So we'll start with this 9th weekend, and followed with the 16th weekend, 23rd weekend, and this 30th weekend, and followed by this August 6th weekend, and then 13th weekend. So it will be purely around six weekend to 7 weekends. This entire course is going to be spread across, right? And then like, this is why I took it as a weekend batch, because the each and every topics what we are going to cover are going to be very vast, right? For example, if I start with the clusterware installation, that's going to take minimum of 3 to 4 hours. So we cannot complete with 1 hour or 2 hours, and we cannot close the session in 1 or 2 hours. And also because of that, we kept it as a 4 hours on weekends, Saturday and Sunday. And then why I kept it as a weekend classes, once I explain these topics on Saturday and Sunday, and then you will be having an entire 1 week to practice or to analyze each and every topics whatever I explained. And then by the next weekend, you can ask any questions or queries, or you can clarify during the week itself, so that when it comes to next weekend and when I cover few more topics, you can again get 5 more days. You can practice it, and you can ask any questions. That's the reason we kept it as a weekend, because we don't want to rush and close the complete the course. I want everyone to understand, learn, and practice, and ask questions. If I know the answer, I can immediately respond. If I don't know, or if I cannot remember, I can discuss, and I can do some research, and I can get back to you on that. So that's how everyone can learn, and we'll give a lot of time. And also this is taken it as a 4 hours on Saturday and 4 hours on Sunday, uh, because based upon many of the feedbacks. I used to conduct it as a 8 hours on Saturday and 8 hours on Sunday. It was like too much. People felt that 8 hours in both the weekend, Saturday, Sunday, it's gonna be like they're losing those weekends. And uh, that's the reason they requested me to make it as a 4 hours, so that at least they finish this 4 hours, and then later rest of the day they can spend with their family. And if I cover 8 hours on Saturday and 8 hours on Sunday, it will be too much for them. So because of based upon these all feedbacks, I especially formed this course, uh, especially on the weekend, Saturday and Sunday, and that too for 4 hours, limited to 4 hours on Saturday and Sunday. Right. So that's about course duration, and then the course timing. The course, coming to course fees will be 15,000 Indian rupees. And then what else? Yeah, and then coming to important factors, once you register for this course, and then you will get access on all the PPTs, workbook, lab materials, and softwares, patches, and ready VMs, and previous batch recordings, basics of database recordings, your daily logs, and everyday classes will be recorded and uploaded to Google Drive, and you can download them into your local laptop and you can watch them. And also we have this dedicated WhatsApp group, and we can do all the communications on that group, and you can ask any queries, questions, whatever you have it in your organization, whatever your project you're working. And if you need any help, or like if you got any task and you're not able to proceed further, you need some help on that, you can discuss in our group. So everyone are actually participated in that, and then we will give you a right direction or give you some hints on that how to proceed further. And then one important factor is these WhatsApp groups will be there forever, and you can, after this course also, you can post any queries, questions, or you can ask for any help, so we'll be there to support on that. And also whatever this recorded session, right, will be uploaded to Google Drive on the same day. You can watch it. If you're not able to join on that particular day, you can go ahead and download it and you can watch it. There's no restriction at all on this course material. Even you can download it into your local laptop, or you can watch it on our Google Drive. There's no restriction at all on this material. Right, and then one important factor is once you register for this course, once you complete this particular RAC course, after a certain period, like after 6 months, if you want to brush up yourself and you want to re-attend this next batch, you are allowed to re-attend. You don't need to pay any extra amount on that. You can just ping me, or you can ping me in our group, WhatsApp group, and then you can rejoin the course. You don't need to pay on that.
I have
Yeah.
a question, sir.
Yeah.
Like in the future, if you plan to for a 21C cluster and database course, so we can join that one also, right?
All right, you can join. No issues on that.
No need to pay. Okay.
No need to pay. Yeah, no need to pay.
Okay. Thank you.
Right. So again, I say I'm very much interested on this. You can see this Oracle Ready VMs, right? What exactly this Ready VMs, right? If I go back to my course content here, this is what starts here. Chapter number 1, 2, 3, 4, up to this chapter number 8. It's gonna be like complete installation and configuration of and setup of your 2-node rack. And then I'm sure if you try installing in your laptop, you're going to take at least 1 day, or at least 2 days, or 1 day. First time you're going to take at least 4 to 5 days for the first time when you try to install your rack setup. At least you're going to take 1 week. And once you practice and be familiar, at least you need minimum 2 days or 1 day in order to do a 2-node rack setup. And what we did here, we have already uploaded certain ready VMs. If I go to my RAC course material here, if I go to my ready VMs here, there are like so many ready VMs here. Like you can see your 12C rack setup with the Oracle user. You have 2-node 12C rack setup. I have few more rack, 11G rack, and then other racks. I'm gonna just upload it here after this session. You can just download this 2-node rack, that 12C rack, and you can configure in your laptop. Within 5 minutes, your cluster setup is ready. And then you have a rack setup with ASM and with database as a grid user, ASM as a grid user, database as a Oracle user. So these three are 19C1. So you can use this entire setup. It's a 2-node rack setup. Download it and use it in your local laptop. And then we have a 2-node rack setup, ASM and database with Oracle user. So with a single user, we have configured both ASM and rack here. And then again, we have a rack setup, only ASM installation with a grid user. You can just download this and you can practice your database installation here. So there are various labs. Again, there are so many labs. I'm just going to upload it after certain days. You can just download it and you can configure it, because each and every topic, for example, if you're doing a clusterware upgrade, right, you can just download this 12C one and you can try to do a practice of your 19C cluster upgrade. That's the easiest way you can do it. Otherwise, you have to configure your 12C rack setup and you have to upgrade it to 19C. That won't take a week for you. So these are interesting things what you get it in this particular lab or course material. Right. Hey, yeah, Kasto, tell me.
Yeah. So you have recognized me with my voice. Okay.
Right. Yeah.
Yeah. So, sir, there is a term, rather to say, there is a service in RAC that is LP scan.
Okay.
Yeah. So, is it a mandatory part of RAC?
Like most of the customer, like they will never use that LP scan. Yeah, they're like, again, if you go in the advanced level, in the scan itself, that various configuration they will do it. Again, that depends why we need and what are the use cases. Yeah, I'm not sure in my career. I never seen any customer using this LP scan.
Okay.
So that depends upon the network what they're using it.
Okay. And that is a part of the networking only, right?
Networking, yes.
Okay. And sir, one more thing, can you show like how to download the Oracle 21C, 18C, all those versions from the e-delivery, because I'm not getting all those versions there.
We'll start that. Yeah, we'll start, not an issue. We'll start that on. Once we start, like I can show you all of them. Once we start with the installation, right, we have to download all those softwares, patches and all. I can show you that once we start our regular course. Right. Any questions so far, guys? Like, for this course curriculum or the course duration or the course structures or the course timing or the course fee structure? Anything you can feel free to ask. Otherwise, I can go ahead and then I can start with some of the basics of RAC for today.
Shall we make the payment fees in 2 installments or just one?
Yeah, you can go with that. You can make with the installment, not an issue on that.
Okay.
Right. Some important things. We have my blog. I used to regularly write few technical content, so you can pretty much go ahead and then follow on that because this is one I think on June 28th. What I written this one, DB start and DB shutdown automation. How we can make use of this DB start and DB shutdown. These are the two automation script default built in with Oracle Home. How we can use that, like, regularly I used to post some technical content here. We can pretty much follow on this. If you're looking for some of the content, they're like, you can go to database and a lot of things already uploaded here. You can just go to each of those topic and then watch that. And then hope like most of them will be following me on YouTube channel. That's also one of the public platform, publicly available, and you can go to YouTube and search for Malik 034, and then a lot of videos I'll be uploading or keep on posting on that. You can just regularly watch them. And then we have a public Telegram group, a lot of discussion. Many people will be having a lot of issues, queries, questions, and a lot of technical discussion will be happening on that. Pretty much you can go join my Telegram group, Malik 034. If you can have that Telegram app and then search for Malik 034, join on that. These are like public groups available outside. Anybody can participate on that, and then it will be like just to enhance our technical skills, and you can post queries. Anybody can answer on that, right? And then whatever we just talked about is all our course content, and the lab exercise. Everything will be like just go ahead and then go to here. Like we have particular ebooks, which have a lot of ebooks. You can just download it and watch them. And then some of the importance of the patchings and what are important factors. And then this course PPTs, and then your course materials, and then the lab exercise, whatever we're going to use it in this particular course, all the lab exercise, and then the RMAN backups and recovery scenarios, and then your upgradation of GI, the grid infrastructure, as well as your database upgradation. You can just follow that. And then everyday recording will be uploaded here on this particular drive. You can just download them, or you can watch it here in the Google Drive itself. Right. Yeah, that's
so are we covering a performance tuning part of Oracle Drive?
No, no, it will not be there.
Okay.
Right. With having said that, all these details, some of the prerequisites, it will be some questions here on that. What is the course fees? Yeah, that's I'm gonna. Soon you can ping me on my uh, let me post my number here on my WhatsApp number 9880616 So you can post me here. You can ping me on my WhatsApp number. I just posted my number here in the chat. You can save this number and then you can ping me on my WhatsApp. Any questions, queries after this course, I can guide you on that. There's some of the prerequisites for this particular course. You should have some understanding of your Oracle basics, Oracle architecture, and you should work as a Oracle DBA. If you are not worked as a Oracle DBA, I don't think so. Like you can easily catch up or quickly, you'll be up to date when we start our course because, that's the mandatory prerequisites. You should understand basics of your Oracle, and you should be worked as some of the basic administration tasks in database. And then you should be understand with the Oracle architecture. Then only this rack will be very easy to understand. Otherwise, you'll not be able to. You will be like lost in the middle. And then if you know your ASM basics and ASM storage structure, then that's well and good. If not, then we'll be covering from the scratch. So anyway, in this particular course, we'll be covering ASM from the scratch, not an issue. If you know that already ASM as part of your standalone database architecture, if you already know the ASM basics, that is good. Like, you can easily, pick up the things here. If not, then not an issue because, we'll be covering this ASM and storage from the basics. And, uh, you know, you should know your various backups and recovery strategies. Um, for example, your cold backup and your hot backups and your standalone database backup. If you know all of them, that's well and good. Because in this particular RAC course, we'll be using only RMAN backups, restore recoveries, and RMAN clone. We'll not be using anything apart from that RMAN. So if you are like uh, not aware of this cold backup, if you're not aware of this hot backup and all, so again, that's going to be pure basics. So that will not be covered here. Whatever we are going to cover here, it will be on only RMAN backups, RMAN recoveries, RMAN cloning, along with your all the RMAN tuning parameters and along with your RMAN architecture, how RMAN looks and what are the RMAN properties. All those will be covered here. But if you know already RMAN, basics of RMAN, that's well and good. Otherwise, again, RMAN will be covered from the scratch here. Right, those are like prerequisites. And on top of that, as I said, you should have a minimum of 16 GB RAM on your laptop or desktop, and you should have 100 GB of hard disk. So those are like prerequisites for this particular course. Right. So, and then this is purely what we covered as part of our database, demo classes yesterday and day before yesterday. We conducted a database course demo classes. You pretty much, I can share those links. You can just watch them. But I'm not going to cover this basics of this one here. What I'm interested is I'm going to cover RAC architecture or RAC basics here. So whatever this database course demo classes what we conducted, I'm going to share with everyone, or else I can quickly share those two demo links here. Already I have that one. These are the database demo classes what we conducted yesterday. I request everyone to go through that. I'm going to ping it here in this particular chart here. Just save these things. These are like two demo classes conducted yesterday and day before yesterday. Just watch them. These are the demo classes what I'm showing it here. These are all covered as part of our database demo classes and networking. So what I'm going to cover here for today, some of the basics of RAC architecture and what is RAC clusterware and what is the difference between your standalone and RAC and how we can, I'm going to quickly jump into my one of the RAC setup. I can show you that how we can identify your scan IPs and RAC IPs and other VIPs and the stuffs here in a minute. Right. So any questions so far, guys? Like your regarding the course or the course content, course timing, course fees, or the
Yeah,
lab
Malik.
activity?
So
Yeah,
I was in your blog that you said about the course details. It
yeah.
just says about registration. It doesn't have a payment link.
Yeah, you can ping me. I pinged here my WhatsApp link, right? You can ping me on my WhatsApp link. Probably I can share that payment details.
Okay, sure. Thank you.
Or else I can quickly I can post it here in the chat here. Or else you can reach out to me with on my WhatsApp. Anything is
Okay,
fine.
sure. Okay, I will reach out to you. Yes.
All right.
Thank you.
Anyway, I can post it here in
You can
the
post it here also. Yeah.
right. Yeah, I posted here in the chat. You can save it. Yeah, let's quickly jump on to the Kadir again. Your raising hand. Any
Yeah,
question?
Malika.
Yeah.
Yeah, what I'm asking you is, as you said, maybe I missed, I'm not sure. We are also going to see the data guard configure, right, on this either on 12C or 19C RAM?
Data guard, I will take it as extra class. We will do one already taken as I think a few months back. I took a rack to rack data guard configuration live demonstration. It was a public that was quite easy. I can cover it as one extra topic here. Rack to rack data guard configuration. And also, I think I uploaded that master document here uh, in this particular course, I believe here. I can go through that. I can show you one setup how we can
That is
configure
also
that.
very important, sir. Rack data.
Yeah, no, I can show that. Again, as I said, right, it was an easy topic. I already did a one live webinar publicly on last few months back. It was a 2-node rack to 2-node rack data guard configuration. Yeah, I can show you one demo on that.
Yeah, can we have one switchover activity
Yeah,
once
we
we
can
have
do
set up?
that one. Right. We can do that one. Once we set up, we can do switch over, failover, and we can do that roll forward. Yeah, these are
Yes,
activities we can do that.
yes, that is important. Nowadays, I mean, you know, right? I mean, we've been increasing the experience on each day. People are expecting this.
Yeah, we can do that one. Yeah, we can do that. But only thing is, uh, it'll be very difficult for you guys, because if you want to do a 2-node to, I can show you it on my lab because I have a cloud subscription. I can spin up a number of VMs. I can do 3-node, 4-node, 5-node rack, 6-node rack, not an issue. But when it comes to your own lab setup, in order to do 2-node rack to 2-node DR setup, you have to spin up 4 VMs in your laptop. So you should have 32 GB of RAM in your laptop. That's
So
one of the
are you
concerns.
using OCI, sir? OCI?
No, I have all the cloud subscription. I got, and to be frank, we got, I got some subscription because, since I'm a Oracle is certified with Oracle, right? So I got some, subscription from Oracle for the Oracle cloud, and also I have my own AWS and Azure subscription.
Okay.
Right. Okay.
So,
If
so I had one doubt. Is it possible to add like a OS level semaphores parameter for which is recommended for rack configuration?
what all semaphores, what you are looking in that?
Like some for installing some mandatory parameters from.
Yeah, we can do that. And there are soft limit, hard limit, open file, no proc, like some of the
Yeah, that
parameters.
kind of parameters, yes.
Yeah, there are Oracle made it so simple. Once you install that prerequisite RPM, automatically
Okay.
Oracle will set it for you. The moment you do, I'll show you that. So
Sure.
now that was the earlier days. We used to struggle that setting up of those parameters. Now Oracle made so easy that Oracle. This is the one RPM.
Okay.
For each and every version, they made this prerequisites RPM. The moment you install this RPM, you don't need to set up all those parameters. Automatically, it will be set for you. You just do install Oracle Database Enterprise Edition 19C. Automatically, all the semaphores are set for you. You don't need to tune it. In prior to 11G release 1 and all, we used to manually sysctl.config, go there and then edit all those semaphore configurations. But when you install this prerequisites RPM, you no need to set all of them. Automatically Oracle will set it for you.
Take it.
Right. Let's start here. If anybody has any questions, feel free to ask. Otherwise, we can quickly jump on and then we'll cover some of the basics of RAC and other things for today. Right. I'll take it as a no going forward. Going ahead now. What's the differences between your standalone and RAC? Um, we know like standalone is like one-to-one mapping, one database instance mapped to one database, and it's like one-to-one relationship. And if there's hundreds or thousands of connections, all will go to that single instance, right? And then in case of if that instance goes down, it's a complete downtime. But whereas in RAC, we have hundreds of instances, like we have multiple instances, instance 1, 2, 3, and then we have a single database. If that instance goes down, you have other instance to survive. The connections will be failed over to other instance, and then your connections or database continue to work. So that like in RAC, multiple instance to one database mapping, like many to one mapping. I can quickly go here. One of the slide, I think. Do I have it here? Right here. This is my uh, the standalone versus RAC. Uh, your end users or applications, they will be connecting through URL, mobile, desktop, whatever device they use. All will go to your application server, right? All will go to your application server. They might be having a multiple application server or single application server. All will go to application server. From that application server, connection will go to that single instance. From that single instance, it will connect to database. The database will be of any storage, right? Local storage or ASM disk or wherever it is. And in case of if this particular instance goes down, it's a complete downtime. Like nobody is able to connect to my database, even though my database is up and running. The database in the sense your core data files, all your system, sysocs, users, apps, whatever the data files are, those that is called as the actual database. So even though the database is up and running, storage is fine. If that single instance goes down, so you're gonna lose entire outage. Nobody is able to connect to your database, right? So this instance is nothing but this is one of your server, Linux server. In that Linux server, that instance will be running. Instance is nothing but your memory plus background process, combination of your memory and background processes, which will be started here. Some background process and memory will be allocated from this particular Linux server. That instance will be running here. That instance will be accessing this particular data files. That's a database. So that data files will be resides under ASM or will be resides under the file system. That file system will be on that particular Linux server, local file system, or NFS, SAN, NAS, or your ASM storage, anything, right? So that like that's kind of a one instance mapped to one database, like one-to-one mapping. If that instance goes down, it's complete downtime. Like nobody is able to connect to your database. Nobody is able to access your data files. That's a standalone instance. When it comes to RAC, like anybody connect from mobile, URL, web application will go to your application tier. From application tier, connection will go to instance 1, instance 2, instance 3, any one of that. And then these are your, as I said, these are your Linux servers. And then in that instance will be running instance 1, 2, 3. It should be a 3, I believe, or 4, 5, whatever you can. It is a 3-node RAC cluster here. And if this particular guy who connected to application server 1 connected to instance 1, and if this instance goes down, and we have TAF, transparent application failover, and if he's using a scan, automatically his connection will be failed over to second node, and his connection will be continued to run. Again, in the Oracle has a limitation. If he's doing only select queries, then select queries will be failed over, and then it will continue to run from that. If it is a DML or the DDL, he has to resubmit that query again. DML or DDL failover is not supported. Only select queries are supported in the failover. But his connection will be failed over. Whatever he is, like whether doing a select query, update query, insert query, delete query, whatever it is, his session will be failed over to any one of the instance. But if it's a select query, it will continue to run. You no need to resubmit it. But if he's doing a update, insert, delete, he has to resubmit that a job, or he has to resubmit that query again. That's a fail over here. So there will be like multiple instances will be running, and they will be mapped to single database here. And then this will be stored under ASM disk group. And if any one of the instance goes down, there will be like other instance who can sustain that incoming connections. It's kind of a high availability, one of that important feature with the rack. Right, so that's about the differences between your standalone and rack. And then if you can see Oracle environment, uh, in case of standalone, as I say, one-to-one mapping. In case of rack, it will be like many instances, many to one mapping. Many instances are mapped to one instances. And in my career, I seen it 64 cluster database, 64 rack nodes for one of the customer. I've not seen more than that. 64 was the one what I seen it for one of the customer, right? And then like
It's in,
this is
it's in
just
India, out of India. It's in China, I guess.
no, it will be long back when I was in Oracle. I worked, I believe. It is US customer. I don't know. I remember, but I can't remember the customer name. But 64 node is the one that was the highest rack cluster I worked in my career, and that too just to check for database status and other things. Not much on that server, but yeah, it's a huge one. Other things, some of the characteristics of your rack. You can just read the just writing, like I don't want to read that, but I can just high level, I'll tell you. You can configure your rack instances by setting a parameter called instance underscore number or instance underscore name. You can set up those parameters inside each database, and then you can configure it multiple instances. For example, if you configure like max instances equal to 3, and then you can configure 3 instance. You cannot configure more than that. For example, if I have a 4 node rack cluster here, like I can just take 4 node rack cluster. If I set a max instance equal to 2, then I can run only instance 1 and 2. I cannot configure on 3 and 4. So these are like parameters you can you can set it up each of those database, and you can restrict that number of instances or number of 2 node rack or 2 node rack database or 3 node rack database. You can configure that. And then some other things on this particular rack. I'll just take a 2 node rack example here. I have a 2 node rack here, and then your ASM1 will be running here, and your ASM2 will be running here, and your database instance 1 will be running here, and your database instance 2 will be running here. And then we have redo logs for this particular thread 1, and we have redo logs for this particular thread 2. Each of those rack instance has its own redo logs, right? Because I cannot have a common redo logs and then both the instance can map to that redo logs. That's not possible. This instance should have its own redo logs, and this instance should have its own redo logs. That's one thing. And then once they have a separate redo logs, and then we have disk groups, and then I can say this is my data disk group. I can say my redo disk group, and then I can say my archive disk group. You can create multiple disk groups. So here all my data files will be there. My both instance will be accessing my data files, and whatever this redo logs, whenever the log switch happens on this particular instance 1, this redo log will be copied to your archive location. Whenever log switch happens on this particular instance 2, again this is also going to generate one of the archive log here. Both the instance will be keep on generating the archive logs inside my shared ASM disk group, right? And then you can put your redo log 1 here, and you can put multiplex redo log 1 R1 and R1. That's a multiplex of your redo logs. You can put it on one data, one you can put it on redo log disk group. And again, this redo log 2, you can put one copy on your data disk group. That's the redo log 2, and then you can put one more redo log, multiplex redo log on the redo log 2.
So basically what I'm trying to say here, your data files and your control file, and then for this particular database, whatever the DB1 and DB2 instance, for that you will be having a control file. You can have a C1 here and you can have a C2 here. You can have your control files and into your disk groups. So what I'm trying to explain here, your database instance will run on each of those cluster nodes. We can call it as a cluster nodes. Cluster nodes are nothing but we can call it as a cluster nodes, or we can call it as a cluster instances, or we can call it as a rack nodes, whatever name it will be like referring to that Linux server. And in that your database instance will be running. And that database instance is nothing but that's a basic architecture, like it's a memory plus background process. All the background process will be running under this server, and for this particular rack instance too, all the background process will be running here. Memory will be allocated from that particular RAM. And then these are like instances will be running at your server level, the node level, and all the underlying files, right? Your data files, your redo log files, archive log files, control files, your flashback logs, and your password file and your SP file, everything will be kept under your ASM disk group. So that's what we're going to talk about here. If you read all of them, this is what I explained here. All the underlying data files will be inside your ASM disk groups, and only that instance will be running under that cluster nodes. And that instances can be limited by setting this max underscore instance parameter. And then how I can know whether it's a RAC database or not. So just connect your database, and if you do a show parameter cluster, if you say cluster database equal to true, then it's a RAC database. If it's a false, then it's not a RAC database. For example, if I go here, I'll just go to one of my lab here. I have multiple database here. So this is one of the node. This is my ASM1 is running here. And if I do ps-ef, grep ASM1, my ASM2 is running here. First thing is like, how to check how many cluster nodes on my server. So I'm just going to set my environment to plus ASM1. The simple command is OLS nodes. The moment you run this OLS nodes, it's going to give you node 1 and 2. It means it's a 2-node rack cluster, right? The simple command. Again, this OLS nodes has some more parameter you can pass it. It will give you IP address and other things, pinned and unpinned, or all those things you can get it. So this is a 2-node simple way to check. It's a 2-node rack cluster. How I can verify it? Like I have my ASM1 is running here, and I have my ASM2 is running here. Node 1 and node 2. It's a 2-node rack. I have one database called single here. I just I'll go this Oracle Vara 19C. Or else first I can go with this Vara CDB, and then SQL plus /SDBA. And then if I do show parameter cluster, the moment I do show parameter cluster, the moment you see this cluster database equal to true, and then it's a RAC database. If it's a false, like, for example, if I connect to this Vara 19C, SQL plus /SDBA, again, I can run the same command, show parameter cluster. And then the moment you see cluster database equal to false, it's not a RAC database. This Vara 19C is not a RAC database. So typically in RAC database, the naming convention goes like this. The moment you do ps-ef grep asmon, the moment you see this suffix, right, 1, it says it's the single the instance 1 for this particular RAC database, which is running under this node 1. And if I go to node 2, I can see cdbdb instance 2 here. So most of the time, most of the environment will end up with this instance number 1 and 2 and 3 if it's a RAC database. That's the one thing you can verify. Like the moment you verify your cluster database equal to true, and then that indicates it's a cluster database. Then how many databases are, how many instances are configured, right? So cluster database instances equal to true, So that indicates it has a 2 instances configured for that. So you can verify using srvctl config database -d, and then I can give just database name. Oh, okay, it is not set. I'll set the environment once again. Right, if I do srvctl config database, here like directly I can go into here database instances. I have instance 1 and instance 2 configured here, and configured on the node 1 and node 2. By looking at these 2 parameters, I can say, okay, this database is configured as a 2-node RAC database. And first thing is whether it's a RAC database or not. I can directly connect to my database and I can check show parameter cluster, which says, okay, cluster is configured. This is a cluster database, and where all these cluster instances are running. I can verify using the cluster instance equal to 2. It says it has the 2 instances, and then quickly I can go ahead and then check srvctl config database and database name, and then this is the properties for that particular database, and then I can quickly look for these 2 here, my instance 1 and instance 2 configured to run on node 1 and node 2, right? So that's a quick things you can verify it at your database level. And then if you go with this one,
Malik, I have one doubt.
Yeah.
As you said, select operation, when we perform select operation in RAC database, when node goes down, it automatically switch into the what are currently running nodes, it automatically fail over to that particular nodes. When it comes to normal operation, it got failed. Once again, we have to execute the same command, right?
Right, you have to resubmit that.
I also know that, but if the same scenario exists in standalone database, instance recovery is happening that time. Once SCN is perfectly matched with each other, then database is getting up, then database in consistent state, right?
No, I did not get that. Come again. Standalone instance, right?
If the same scenario is existing in the standalone database, database is instance is unavailable at the time, then it goes to down state. When we brings the instances startup, at the time goes to instance recovery, right?
No, if your instance is abnormally shut down or due to some network or anything, if your instance crashed, when you start it at the next time, your SMON will do that instance recovery. Like it's gonna do that. It's gonna read your committed transactions. It will do a roll forward and it will look for all the uncommitted transactions, and it will refer your undo blocks, and then it will go for a roll back for all the uncommitted transactions.
Yes. But in this case, it is switched into the next available node. Okay, when node 1 is brings up, then what is the action has performed Oracle? I want to know that.
Node 1 will brings up what? Node 1 will what? It will bring up.
If suppose when DML has been performed during that DML execution time period, node 1 is unavailable due to some.
Right. No, like your SMON will take a the moment whatever the transactions it will gonna do that one, right? For example, node 1 is connected and it has done some insert operations and the node went down, and the automatically connection will go to that any surviving node 2 or node 3. And your node 2 will directly query your there's a GRD, there's a called GRD, the global resource directory, which will be running under your one of the cluster master node, and it will that instance will communicate to that master node, and then it's gonna do that whatever if there's a uncommitted transactions, it's gonna get those uncommitted transactions, and it will do all the rollback of all those uncommitted transactions, and then the user has to resubmit whatever the query you want. So this all be kept it under your GRD, global resource directory, which will be running under your master node. Any one of the cluster node will be master node. Master node will be having those information, what all the uncommitted transactions from that particular node.
Okay.
Yeah.
Thank you.
Oh yeah, that will be like advanced topic, probably not at this point. Like, many people will be like not having a doubt on that what is GRD, and then how I can query which is my cluster master node. Yeah, once we start regular classes, you'll get to know like how we can query for your master node and what is that GRD table and other things. You'll get to know that. Right, so that's one thing. Let's go further. This is a high level configuration of your cluster. Your all the applications layer. So this your all the from the application side, all the users connection will go to your scan. Your scan will pass the connection to the node VIP, and from that node VIP, it might be either instance or the listener or the service. You're going to connect to that particular node, and then it will going to access my database. So this is on one of the node, right? One of the node one Linux server. In that, you'll be having your VIPs, services, database services, instances, listeners, your grid infrastructure, your ASM, your cluster-based software, and that underlying OS of that particular Linux server. The same thing goes to your other node as well. And then these are like, you can have a number of cluster nodes. If you have 4 node cluster, underlying OS will be there on all 4 nodes, and you will be install your grid infrastructure on all the 4 nodes. That grid infrastructure is nothing but your ASM home plus your clusterware home. Remember in 10G, prior to 10G release 2, your we used to install your ASM home separately. We used to install cluster home separately, 2 different directories we need to install, and then form that cluster. But in after that 10G release 2 onwards, Oracle combined ASM home plus clusterware home together, and they came up with the grid infrastructure home. So if I go here, this is my grid home. If I do cat etc Orac tab, sorry, cat slash etc Orac tab. So this is my clusterware home here. So that's not a clusterware home. This is my grid infrastructure home. So this grid infrastructure home contains your all ASM home plus your clusterware home together. They made it as a grid infrastructure home. And then you should be having a number of listeners, ASM listener, local listeners, and so many scan listeners, and all each of those nodes. And you'll be running multiple instances on those nodes, and those instance or database will be having the respective services. And then each node will be having its own VIPs. So this is high level, the cluster level services and the local individual node level services. That's about high level how that clusterware configuration looks like. So this is what I explained how that standalone versus rack, and then the failovers happens. So this is comparison between standalone and rack, but at the high level overall architecture, your client will connect to your database using a public network, and via that public network, it will connect to your rack nodes, any one of the node via node VIP, and your public network and your node VIP and scan VIP all will be in a public network. And then each of these node will be communicating with a private network. And then all those will be like each of those nodes will again communicate with the storage, shared storage via private network. So all your VIPs, your scan IPs and node public IPs, all these 3 IPs will be in a public network, and there's a one set of private IPs between the node communication and between the node to storage communication. That's your private network, right? Let's go here. I can explain it here. Right. So this is high level architecture of the rack. I explained about public network. I explained about the private network and scan. Your VIPs and the public IPs and the scan IPs. These are the 3. Ideally, we will get it 4 kinds of IPs in a rack. One is a public IP, one is a VIP, one is a scan IP, and other one is your private IP. These are the 4 types of IPs you're gonna get it. So I can explain it here in a minute. Let's take this paint. Okay, I can take a 2 node rack as an example, right? 2 node rack. This I can make it as a node 1. This is my node 1, and then this is my node 2. This is my 2-node rack. This is my host name, node 1 and node 2. And then this particular node will be having one IP, 192.168.1.100. And then this particular node IP will be having 100, 102, and then I can make it as 101 and 2. Just ease of understanding. 101 and 102. So these are your public IP. I can tell this as a public IP, right? So these are your public IPs associated to that node. And then this node will be having a VIP. I can say node 1 hyphen VIP. So the IP address will be, I can say 101, 102, and then 103. And then this also having its own node 2 hyphen VIP. So I can say this is 104. So this is a VIP, right? So if you observe this node IP and then the node VIP, both are in the same subnet. This is called subnet here. Whatever you are saying, this is called subnet, right? So they are all on the same subnet. So we already got two types of IP. One is a public IP and the other one is a VIP, right? And then we got some set of for this node 1 and node 2, I can say scan is my name of the scan, and then I can say scan has IP called 105, 106, 107. I can say this is my scan IP. This is my scan VIP. So I can say this is my scan VIP. Right. So we got three types of IPs: public IP, VIP, and then the scan VIP, or they will call it as a scan IP. So you can call it a scan IP or scan VIP. So because your scan will be of a VIP, not a physical IP. So I can say again, this is also on the same subnet here. And now we got one more IP, that's a private IP. I can say this particular node has one IP. I can say 192. What a second. I can say node 1 hyphen PRIV, private IP. So that will be in a different subnet, 192.168.2.101. I can say node 2 hyphen private IP. So this is, I can say, private IP. Right. So there are 4 kinds of IPs when it comes to your rack setup, your clusterware setup. One is your scan VIP. We can call it as a scan VIP rather than scan IP, because you understand one is like, types of IPs. Types of IPs. So there are 2 types. One is physical and other one is VIPs. What are the types of IPs? You can use it in a rack setup. One is a physical IPs and one is your VIPs, right? These are types of IPs I'm talking about. Physical IPs are nothing but, those will be like assigned to an interface. Virtual IP are the one which are not assigned to any interface, right? So this is my node 1 and node 2. I have my ETH0 interface and then ETH1 interface. I have 2 interfaces here, and then similarly ETH0 and then ETH1. These are the 2 interfaces each node will be having. And then for this interface 0, I can assign a public IP. That will be this particular IP here, 101. Right. So just bear with me, like, if you're getting confused, you can just stop me. So this is my one of the interface I'm going to assign. IPs. Okay, these are my physical IPs. If any IP assigned to an interface, that is called a physical IP, which will be assigned by your DHCP server, or you might be preserved in your DNS server, right? So that is your physical IP. And I have one more interface. I'm going to assign this particular private IP here and then here. Understand here, right? So your node IP and then the node private IP, those two are always physical IPs, right? If you see here, this one and then this one and then this one and then this one, these two are your physical IPs. So your public IP and your private IP, so these two are your physical IPs. Physical IPs are always bonded to your any of the interface, and your VIPs are not bonded to any of the interface. That's the
On
first thing.
second node, private IP should be supposed to be 102.
Yeah, it's a 102. Sorry, it's a 102, right? So remember, like types of IPs, if they ask in a rack, we are going to use two types of IPs. One is the physical IPs and other one is the virtual IPs, VIPs, we can call it as. Physical IPs always bonded to any of the interfaces. If you see, you can do IF config on your server. If you see any IPs bonded to or tagged to that interface, that's a physical IP, right? And then these are the two types of IPs, physical IPs and virtual IPs. And what are the different, like if they ask what are the different various IPs, you're going to use it in your in your cluster, where you're going to use a scan VIPs, you're going to use a public VIPs, and you're going to use the VIPs, and you're going to use the private VIPs. These are the four types of different IPs needed for your clusterware setup. But when you talk about networking point of view, there are only two types of IPs. One is the physical IPs and one is the private IPs. So physical IPs are your public IPs and the private IPs. These two are like your physical IPs. Rest others are your VIPs. So your scan is also VIP, and your node VIP is also a VIPs, right? And then where these VIPs will be pegged, where these VIPs will be tagged. So those VIPs will be tagged something like this. You have interface Ethernet 0, like it will be like Ethernet, sorry, Ethernet 0:1, and then you can see this particular VIP 192.168.1.103. So since these are VIPs, these are not physically able to associate to any of the interface. They will take one of the interface and they will peg it using this VLANing concept. Internally, cluster will do this one. This one thing it will happen here, and then again, sorry, again it will gonna do the same thing here. It will take it as a one, sorry, one only, and then it will, your IP will be, sorry, I made a mistake here. Right, so it will be like this. It's 103, and then it will be like 104. You can stop me if you guys getting confused here. Like these are your VIPs. So that this particular node one VIP 103, and then that node 103, it is pegged to interface ETH0. Why it is pegged to ETH0? Why it is not pegged to ETH1?
Same subnet.
Right, that's one of the consideration. Your ETH0 physical IP subnet is 1, and your node VIP subnet is 1. It has to peg with that public interface, whatever it is having it, ETH0. And then what about these scans? I have 3 scans here, scan 1, 2, 3. These 3 scans, if you see, observe here, I have 1, 1, 1. Subnet is same, public subnet. And then these scan also will peg to your ETH0. But I have a 3. In your cluster, 2 node cluster, if you go and check it out, you may see 2 scans here, 1 scan here. Or you may see 1 scan here and 2 scans here. It may go anywhere, like your scan will run on any of the nodes. So in that case, it's gonna be like this. Your ETH0, that interface, and then it's gonna peg with the VLANing 2, and then it will be your 105. And then here I can make it 2. 1.
Can we have more than 3 scan IP?
Here you can have it.
Okay.
So it will be 5, 6.
In which case
And
it is required?
No, 3 is minimum required. If you have 3, that's more than enough. That's smart enough to handle it. But if you have more, again, no use at all. Like it's gonna
No,
do the
what are
same
the
thing.
use cases of that?
No,
Having
like
a more IPs.
it will be like when it comes to scan, I'm gonna explain it. Right now, I think it's too early when I explain it here. There are 2 concepts here: client side client side load balancing. Your server side load balancing and client side high availability. Only those are the 2 things the scan will be defined. The scan, 3 scans will act as a high availability for the incoming connection. For example, your client connection 1 comes, that client connection 1 will take this first IP and it will connect to any one of the node. And client connection 2nd comes, it will take 2nd IP and it will connect to any one of the node. Client connection comes 3rd, it will take 3rd IP and it will connect to any one of the node. So assuming that your client connection 1 comes, by some reason like node 1 is not available, it will quickly go to node 2nd IP. If the 2nd IP is not available, you can quickly go to 3rd IP and it will connect here. So it's kind of for the client connection, it's kind of a high availability. If you have 5 IPs, and then it will be like redundancy, 5 times the redundancy. If the 4 IPs are not available, client connection go to the 5th IP. Like, it is only that use case. Like, your scan IPs are useful for act as a high availability at the client side. So client try to connect to scan name, any one of the IP will be picked up. If that IP is not available, it'll go to next IP. So only for that reason, you can have multiple redundant IPs here. And then having 10 IPs kind of useless, right? You're not gonna use anything. 3 is more than enough. But if the question is, can I configure my scan with the 2 IPs? No. 3 is a bare minimal needed for your clusterware setup. If it's lesser than 3, it will not proceed further. But you can have 4, 5, 6, 7. Again, what's the use case of that? It's kind of a high availability for your client side. For the client connections, 1 IP is not available, go to next. It's not available, go to next. If none of that available, it will not connect to your database. So that's the use case of your scan IPs.
Sir, you
Thank you,
said the minimal was 3 IPs. What was the max?
Max, not sure. One I never thought of, but I seen it one customer with 9 IPs.
Okay.
9 IPs. I saw one of the customer with the scan, but I'm not sure what's the limitation on the max.
Okay.
Yeah. Right. Clear on that? Your scan VIPs, public IPs,
Hello?
VIPs,
Malik?
private IPs. Yeah.
I have one question. How many IP are required to RAC node setups?
Yeah, we saw this setup here, right? How many IPs altogether we did here? Your 3 scan, your 2 node VIPs and 2 node IPs and 2 private IPs. This is all what you need. This is a bare minimal.
11 needs to be 11 IP required.
All right. You can see like node IPs and node private IPs and 3 nodes, 3 IPs on this node 1 and 3 IPs on node 2 and then 3 IPs on scan. So altogether you need 9 IPs in order to set up your 2 node rack. And there's
Okay.
a one more concept. They will go with like this. Node 1 MGMT. And then it'll be your node 2 MGMT. And then here they will go with the 192.168.1 dot, or like you can go with the different subnet like 1.109 or 108. Sorry, 108. And then they will go with 108, 109 here. So these are like, extra redundant IPs. It's not a mandatory. Like, you can have a node management IP, 2 extra IPs. If you consider these 2, it becomes 11. These are like, not mandatory. These are like, optional. So why we need this management IP? Sometimes you're going to install your agent into separate IP so that you can avoid the traffic, your agent traffic, or your OEM console access, right? I don't want to access my OEM console using my node public IP. I want my public IP dedicatedly for my client connection. So in that case, I can configure one more management IP, node MGMT, node 2 MGMT. I can configure in a public network, and then I can configure my OEM on this particular IP range. So I can go with a different subnet also. I can configure here, and then all my agent communication will happen through this particular IP. So that's also you can go, but it's not a mandatory one. But for our minimal IP required for rack setup is 9 IPs, 2 public IPs, 2 node VIPs, 2 private IPs, and 3 scan IPs.
So Malik sir, basically these 9 IPs, you are putting it in 4 physical NIC. Is that correct?
No. Again, as I said, right, only my node IPs and node private IPs are the physical IPs. So only physical IPs need a physical NIC interface, and your VIP don't need any interface. So as I say, like, Ethernet 0 and Ethernet 1, these are the 2 interfaces, and I peg with my node IP and node private IP. These are my physical IPs. Only physical IPs will be pegged to your interface, and your all the scan VIPs and your node VIPs will be like, pegged or associated to any one of those interfaces based upon the subnet.
So basically, there will be only minimum requirement. If I ask in terms of physical NICs, there will be only 4 physical NICs will be required. The minimum required will be 4.
Right.
2 in each node.
Right.
And it is somehow pegged dynamically or however to one of the physical NIC as a VIP.
Right. That's correct.
Okay. That's correct. And is it also correct that the private IP is or the private NIC scan will not be pegged to that
no.
private? Okay.
That is in a different subnet, right? It's a 2 dot. Only whatever the VIPs with the same subnet will peg to that associated interface.
So if you remove the 2 private IPs, so you are left with 7 IPs in total. So these 7 IPs are pegged to 2 physical NIC card. Is this correct?
Right, that's correct.
Okay. Thanks, sir.
Right. Any questions on this?
Yeah, sir. So for your MGMT nodes, is there any like IPs? Is there any linkage with the MGM like management database?
No. It's just I just give the. It's just a management database is a separate one. Like I just given that as a name, management purpose. Like if you are doing some OEM installation, or if you're configuring some third-party agent installation for backups and recovery, you can install it on this IP. Because I don't want, because the moment you configure your OEM or agent and all, agent will push the metrics from your database to your OEM server, right? I don't want to interfere with my public network. I want this public network should be dedicated to my client connection. So I can go with the different IPs where OEM, my agent will communicate on this IP. Just to avoid that, I just given that extra IP here.
And so one more thing, like I have configured my 3 scan IPs in a single subnet, right? So if I configure one of the scan IP in a different subnet, like in the alternate subnet, will that work?
Or? No, it will not work.
It will not.
Hi Malik, Vijay here. Could you please briefly, quickly tell me about that? How does the communication happens between these IPs and I think are we missing the MTU or something? Are you will be covering in next session or?
No, that will be different. Like once we start our regular class,
okay,
we will talk on that private communication.
Okay, communication will be covering now or later?
No, not now.
Okay.
Right. So this is high level. How we're going to set up the rack. Quickly, I'll go to my.
I have one question, sir.
Yeah.
So, well, in case of a 9 scan IP, okay, one of the client asked me to set up with like he has like more than 1 billion client. Okay, they connect to the app. There is a huge load on the database, and ask me to configure a scan load or scan IP with the 9 IPs. Okay, so in that case, I just want to know. It is like a 2-node cluster. I just take the example with the 2-node. Okay, so my one IP is ETH01 will be on the node 1, and rest 8 IP will be showing on the second node, ETH01, ETH02, ETH03, something like this. Huh? Till 8, huh? Does it behave like this?
Yeah, that's correct. Like, ETH0, out of that 9 IPs, you may see
ETH0:1, ETH0:1.
Yeah.
This is
You may see 4 IPs here, 4 scan here, 5 scan here, or you may see 3 scan here and like remaining 7 scan here. Randomly, it will be distributed. There is no control on that. Your scan will.
It will be taken care by Oracle itself. Huh?
Oracle itself, yes.
Oracle cluster itself. Okay.
Yeah. Right. So if I quickly go here on my lab, quickly, I can show here. Remove this all. Clear it out. Okay. I have this 2-node. I have config. I have my interface 1. Public IP is assigned here. And then I have config. So I have my interface on node 2, public IP, like 133. And then this is 4.133. And then this is 4.134. 2 public interfaces, physical interfaces. Go back here, then I have my second interface here. And then it's a 9 dot. It's a 4 dot series and it's a 9 dot series. And go back here. And then it's a 9 dot series. So this is my private IP here. Private IP here and public IP here. And again, private IP here. Sorry, public IP here and private IP here. And then I have C192:1. This is my node 1 VIP. 33 and 34 is here. And then 35 node 1 VIP, again pegged to 192. That's the interface :1. And if I go here, and this is 145 pegged to my, again, same private, public interface pegged here. And then I got a 2 scan here. And then if I go to node 1, I got only 1 scan here. Out of 3, 1 is came on this node 1, 2 are came on node 2. The moment I shut down my node 2, all this interface, all these VIPs will go to my node 1 here. So I'll just quickly shut down my cluster on node 1. .ini, and then we'll stop it for today. CRS-CTL stop CRS-F. So remember, like right now, if you observe here, you have node 1 VIP. This is a node 1 VIP right now currently running under node 2. And this is one of the scan. One scan is running under node 1. These two will be fail over to node 1. Right now I am having 1:1:2:3. Once node 1 goes down, all your VIPs will be failed over to node 2. It become :4 and :5 here. So I'm just going to shutting down my cluster on node 1. Right, so we can see it here, right? Starting off node 1 VIP on node 2. Got it, right? So whatever that VIP will be like shifted to node 2. And your scan also, where the scan? Okay. Anyway, where is that one? Stopping, attempting to stop.
It's at 2677 over there, just a little above.
Attempting, yeah, this one, right? That's correct. So starting off your scan 1, which was running under node 1, it will be again shifted to node 2, right? So now node 1 is completely down. If I do IF config, all your VLAN pegging is gone now. If I do, I have interface 1, interface 2. Those pegging are gone because the VIPs are gone. Like VIPs are failed over. Like you can see only brand new NICs here, which are have pegged with that physical IPs. Third one, I am not using the third interface, just left blank. Right. So those are gone now, whatever that NICs, whatever that VIPs are pegged here. If I go to node 2 here now, if I do ifconfig, right, you can see you got extra .4, .5. Earlier I had only .3, that 1, 2, 3, and then 4 and 5 were not there. Now we got that 4 and 5, the 4 and 5. The 4 is node 1 VIP, and the 5 is the scan 1. Right, so that's how your failover, the VIPs are failover. But again, if you see, it will be always pegged to that same subnet. It's never gonna peg into your other subnet.
So that means the connection will be failover to the second node.
Yeah, that failover you can verify it here. How we can verify it here? Plus ASM2 CRSTTL stat resource -t.
Sir, the command which you are running, actually we are unable to see because this Zoom tools are showing here on the bottom side. Can you just scroll up?
Yeah, probably I'm gonna share this notepad. I just scrolled up here, like CRSTTL stat resource -t. The moment you run this command and then scroll all the way down, and you can see your node 1 VIP online intermediate, and which is running under node 2 now, and which is in a failed over state. And your node 2 VIP, which is online, which is running under node 2, which is a stable state. So it will be in a failed over state now. The moment I start the cluster back here on node 1, and then automatically your these two, whatever the IP is failed over, will come back here. The moment I do CRS, it will start CRS on the node 1, and automatically whatever this failed over IPs, where are those? These two IPs will come back again. Node 1 VIP and then one of the scan VIP. Right. So that's pretty much what I wanted to cover for today. If anybody has any questions, we can talk. Otherwise, we can stop it here for today. And then tomorrow we can connect again, and then we can see few more topics about cluster resource and some of the startup sequence for my cluster. All right, so I'll just stop it for today. Let's see here. Once my cluster starts, your IPs will fail over here. Right. Any questions, guys, before we wind up for today? Any last minute questions or queries? Right. So if not, then thank you all. Like, we can connect on tomorrow's demo class, and we'll discuss few more topics. Sorry, Amrita, go ahead. You have a question?
No, I was just saying thank you. This was very helpful to know what we're going to have in a real training. And
all right.
Thank you for this one. Yeah.
All right. Yeah. Anyway, like tomorrow also we'll connect again. Tomorrow we'll discuss about some of the cluster resource OCR, some of the local resource OLR, and my cluster startup sequence. The moment I do CRCTL shutdown, CRCTL stop cluster, and CRCTL start cluster, what are the services will get started in which order, and what all files we need to check on that. So few of some more basics, we'll check it out tomorrow, and then we can conclude these two demo classes, right? All right, guys.
One more thing, like have we discussed about which IP is used for which purpose, or it will be covered in the next session, or
that will be like discussed in detail, like why we need a physical IPs, why we need a VIPs. We have a scan IPs, why we need a VIPs. We have a VIPs, why we need a scan IPs, and what's the use of public IPs. All will be like advanced concept. We'll start it once we start our regular classes.
Okay, thank you.
Yeah, thank you, Malik.
Yeah.
Thank you, Malik.
Yeah, Malik. Yeah. Yeah, actually, in this RAC environment for AWS, we are moving the databases, right? So AWS, we don't have this type of RAC setup, and what is that new setup in any? Can you just tell, or how it is going to happen in the, because majority of the RAC environment, they are not going to shift in the AWS environment, right?
There are
currently
like
the banking sectors.
there are some limitations even in Azure and in AWS, how you're going to set up a rack and all. Again,
Okay.
it is subjected to, like, if you get a chance to work on that, immediately you will get to know that how you're going to configure that. Yeah, there's a possibilities. You can configure still your,
Possibilities.
yeah, you can configure your rack on AWS. Even you can configure your rack on Azure, even though they say that it's not a straightforward and it's not a supported configuration, but there are some ways, like, some network level tweaking you can do it, and you can configure it. It is there. It is, you can do it.
Okay.
I have one
Yeah.
question, sir.
Yeah.
Yeah. Please.
So well, mostly, see, we guys only work on the 2-node cluster. Like if a requirement comes for the 5-node cluster, so what is the and we take the OCR and bottom disk in a high redundancy, which is a 5, okay, in 19C. So what is the role of quorum disk here? I'm not selecting any quorum disk here. I mean, why the question? People ask for this. We should have just a majority of the disk in the quorum. Why?
No, for example, right? Assuming that, what you can say, first question, have you tried your quorum disk on your normal rack system, or you only seen in Exadata?
I have never tried this.
Right. So the point here is, if you try to create a quorum disk on normal file system here, normal database server, it will never work. When it comes to Exadata, the quorum disk concept will comes into picture. So, for example, one second, guys, 1 second. See what happens, right? I'll explain it once we start our regular classes. It purely depends upon your redundancy factor. We have a external redundancy, we have a normal redundancy, and we have a high redundancy. By default, external redundancy means no mirroring, no copy at all. And normal redundancy means one original copy and one duplicate copy. And your high redundancy means one original copy and 2 duplicate copies. There are 3 copies here in the high redundancy.
And 1965.
No, this is normal, not 5. Like, I'm talking about the disk group level, your ASM disk group level. Forget about your voting disk. I'm talking about the ASM level redundancy. External, normal, and high. External means no mirroring. Normal means one original copy, one duplicate copy, 2 copies. And high means 3 copies, 1 original and 2 duplicate copies. If you return A, in high redundancy, it's gonna write A, and then A duplicate copy, it'll write it to some other disk. The 3 copies it will maintain. But when you try to create your voting disk inside your high redundancy, it will fail. Why it will fail? Because your voting disk, by default, it will gonna try to create a 5 voting disk when it comes to your normal redundancy. Sorry, when it comes to your high redundancy. When you try to create your voting disk on the normal disk group, you want to try to create it on the 5 voting disk under different disks. But if you don't have a 5 failure groups on that particular high redundancy disk group, you're going to fail that we do not have a sufficient disk to create my voting disk. So in that case, you're going to create a 3 voting disk inside your ASM disk groups, and you're going to create a 2 voting disk into your OS file system. For example, it will go to one OS file system. It's going to mount one particular directory. It will put one voting disk as a OS file system on particular node 1 or on node 2. Those are called your quorum disks. So again, most of the times you see it in your Exadata box, quorum disk, but in normal servers, you never see that one in a normal rack environment.
Yeah, even like I have set up the 3-node rack where so normal redundancy I have chosen the high, which is a 5 mirroring of the disk in the ASM disk group. Okay. So
you need a minimum. No, you need a
there is
minimum
no
of
concept
5.
of quorum there, but still when we just give the interview, the people ask.
No, like I'll tell you what is that. See, first question, first thing what you need to understand, basic ground rule. Your high redundancy means always 3 copies, always 3 copies, not a 5 copies. And then you created a disk group with a high redundancy with a 3 disk. That's fine, that works. 3 disk, 3 failure groups, and then high redundancy, that works. But if you try to keep your voting disk into that high redundancy disk group, it will fail, saying that I do not have a sufficient disk to keep my voting disk, because default internally try to create it in 5 voting disk, 5 voting disk in a 5 different disks. But you don't have 5 disks, you have only 3 disks. And the moment you add 2 more disks into that high redundancy disk group, the moment you create your voting disk, it will spread all the voting disk across all 5 disks and it works fine. But if you have only 3 voting disk, it will keep a 3 copy into your high redundancy disk group, and 2 copies it will gonna keep it into your OS file system, your node 1 or node 2. Under that OS file system, it's gonna create some directory, and it mount that particular mount point, and it'll create those files, 2 extra voting disk into your local OS mount point. Those are called your quorum disk. And if you have enough disk inside your high redundancy, like you have a high redundancy disk group and you have 10 disks in that, and you can go ahead and create your voting disk. All the voting disk will be created inside your disk group, and there's no quorum voting disk over there. It's all inside your disk groups. Quorum voting disk means
why do we need the quorum disk when we can set up our environment without quorum disk? What is the use of quorum disk?
No, not a voting disk. That's a minimum requirement. 5 copies of your voting disk is a minimum requirement if it's a high redundancy. And if you don't have a minimum disk in that particular disk group, Oracle has to forcefully create 2 extra voting disks, right? For example, I have only 3 disks, and then 3 voting files will go into that 3 particular disk, and where you can gonna keep that remaining 2. Oracle internally creates it as a quorum disk. That's the concept of quorum disk.
Okay, that come into the picture when we are.
If you don't have a sufficient disk inside your disk group.
So quorum disk come into the picture when we are just one of the node goes down, then it go to the quorum disk and ask for the available node and make those nodes.
It will be. Yeah, it will be many use cases. No, it will be many use cases. Even in node reboot, or even in your node recovery, like your cluster recovery, your quorum disk will be used. But quorum disk will never come into picture if you have multiple disks. For example, I have a high redundancy disk group. I have a 30 disk inside that. Then quorum disk will never come into picture. Again, remember, quorum disk comes into picture if you do not have a sufficient disks inside your disk group.
Okay. I request you, sir, please, when you just start the course, cover this part.
Yeah. We'll talk on that. Right.
Thank you,
No
sir.
problem. All right, guys. Any questions?
Yeah. So I have one question.
Yeah.
So apart from the budget constraint, what is the disadvantage of RAC?
Apart from the budget constraint, disadvantages of RAC. No, I never seen RAC is a disadvantages. RAC is always more advantages than compared with your standalone.
Okay.
Malik, one question.
Constraint here, right? Most of many organizations will not configure the RAC because of resources and budget constraint.
That will be a primary concern. Only if you compare with the small scale industries, startups and all, they will look all these concerns. But if you go with the large scale enterprise and all, more compared with the budget, your availability and HA is concern for them. Your business continuity is a concern for them, right? So budget is aside, and then RAC is always good practice. As per the MAP best practice, right? Maximum availability architecture. Always go with the RAC database with the DR configured with the RAC database. That's the best MAP practice. Maximum availability architecture.
Sir, but I deal with the so many clients. Now the clients have become very smart. They are started thinking, why should we go with the RAC when we are getting the cloud services, RDS. Okay, and some of the clients are more clever. They just to save the cost, they started asking me to migrate the Oracle database to the Postgres. Just
Yes,
the cost
this-
is 18 to 20 times cheaper than Oracle Postgres. Yeah.
Now, obviously, when it comes to Oracle, one of the bad thing even I say that costing always is high and huge
High
compared to
costing,
any other
correct.
vendor. Yeah. So apart from that, service support and resource will be too much. Like Oracle, nobody can beat in security, features and enhancement. Like Oracle is very good, but cost is always
Okay.
bad part of that.
Malik, one more thing. Like, is it advisable to run this rack setup in cloud, like EC2, AWS? Anything? Just
There is no straightforward. Like it depends upon what kind of application you are running. If it is a OLTP, then I always go ahead and then go with the rack setup in your AWS or even in Azure. Even though they say that they have their own mirroring and they have their own redundancy concept and all, but still, I recommend to always go with the rack. But again, they say that it's not supported configuration and other things.
yeah, but even Oracle providing support in hosting cloud. But I suspect.
Yeah, no, that's what. Like most of the cloud vendors, they will not support the rack configuration on even on AWS and Azure. But you can have the various method to configure rack. Yeah, you can configure. But if it comes to extreme, the issue at the configuration level, obviously they will not support. But I've seen many customers, they will be running, on AWS and Azure. They absolutely works fine unless you get into some disaster scenario. It'll work fine.
Okay, and EC2 they're running in AWS.
Right.
So what they do over the on the cloud, on the fly, they just increase the CPU and RAM to improve the performance of the resources.
Right, you can do that one. No, but only thing is, right, assuming that your high availability, right? For example, I have 4-node cluster. If you run your EC2 instance and configure your standalone database, now I'm running 4-node rack and my connections are distributed, and if one instance goes down, automatically my connection will fail over to other node and it will run. But if you're running your EC2 instance and single node instance, and if that instance by any chance it crashes or goes down, and what's the availability? That's one thing, right? Again, you have to clone. There's method to clone and
rather than going to the infrastructure as a service, just go to the database as a service, RDS.
No, yeah. Again, I don't want to go with RDS. I want to stick to my Oracle. In that case, many people will go to OCI, Oracle Cloud, rather than AWS. Right? I don't want to go out of that.
So in OCI, we have an option to deploy the Oracle rack, right?
Yeah. Yeah, we have option.
Infrastructure as a service or platform as a service?
No, you can infrastructure as a service. If you go, everything will be under your control. You can do whatever you want, right? Okay. Because entire infrastructure will be given. You can spin up a number of nodes. You can spin up your rack, and you can configure your own setup, whatever you want. That's the highest level of infrastructure as a service.
Okay. One more question, sir. Do you also teach the Oracle Accelerator?
No.
Okay.
All right. All right, guys. So
basic understanding. Just the last one. If we want to, do some move, copy, or all of those things in our Linux OS system, that is possible, right? So, but same thing, if I want to transfer any of the files from the OS file system to my ASM desktop, is it possible?
There's a command like ASM copy is there, and we can copy from ASM to normal or normal to ASM. That you can do.
That will be it will work in the ASM command line utility, right? Or
right. But again, if you copy it, the files will not be useful. Like only your ASM can understand only your data file, control file, and read log and archive. If you move any of the other files, ASM will not be able to understand.
No, I'm just thinking, like, if we want to move the control file or parameter files from the OS file system to my ASM, will that work or not? Will it detect the property, it will match or not?
No, like one thing, right? Why you create your control file into local file system? Your control file will be inside your ASM disk group only. Will be in your rack. Your control file will be inside your disk group, not on a local file system.
So, but we can create it, right? We can create the parameter file forcefully in my OS file system. We can give the path, specify the path where we want to create the parameter file.
And then use that parameter file and create your SP file inside your disk group. You cannot keep your parameter files inside your disk group, but rather you can keep your SP file inside your disk group. Yeah, you can use that P file and create your SP file inside your disk group.
Okay.
But you cannot move that and you cannot use it.
Okay. Got it.
But your password file you can copy from OS system, file system to disk group and disk group to OS file system. Because password file is same wherever it is, whether local or ASM disk group, it's gonna be like same.
Okay.
Hello.
Yep.
Yeah, I have one question. After the course, can be able to do the RAC certification? Can you help on that?
Yeah, you can do that one. And again, after this course, you can practice it before attempting to any certificate, right? First you practice it, review some sample questions and then attempt for that. Because I see many people will blindly go for the certification and during the first attempt they will fail. I seen it. You have to practice and you have to do some practice exams and then go for that.
Any dump is available for that? Or?
Dump is a shortcut, right? Like, if you refer dump, you can easily clear the exam, no doubt at all in that.
Okay, but practice is important before that.
Yeah.
Practice is more important than that.
Right. Yeah. No, without practice also you can, again, as I said, like without practice, you can directly go and then refer the dumps and you can easily clear the exam, but no use at all.
Okay.
All right, guys. Let's connect tomorrow and then we'll connect few more topics and then we'll discuss further on that. Thank you, guys.
Thank you so much, sir.
Thank you.
Thank you, Mali. Great. Thanks.